We've developed the concept of using small electric, optionally manned vessels to move low levels of freight around inland and inshore waterways. So the Department for Transport funding that we've received allows us to work very closely with our commercial partner, Williams Shipping. We routinely carry freight across the harbour, which by water is a distance of less than a mile, but by road would involve a round trip of 9 miles, and that round trip would require driving through the centre of the congested city of Southampton. RAD sees mobility as a key part of its future growth, and this project is instrumental in helping us to develop that growth and develop our concept.
Our biggest problem has always been getting goods into the middle of cities sustainably, and trying to do so emission-free has been very difficult. Zero's novel process is using containerised cargo bikes. Now these containers are packed by our customer on a depot outside Bristol. Then they are brought in the van all the way into the centre, where they're dropped off at various locations for our cargo bikes. We want to demonstrate that more deliveries can be made by cargo bikes in urban areas, and we do that by showing that the process of containerised cargo bikes and virtual hubs work, and show that we can do it less than the cost of doing business as usual.
We are Go Metro, a fleet management technology company. What makes our product unique is how seamlessly it integrates with telematics data as an input for the EV transition analytics that we do, and that telematics aggregation is OEM agnostic. So the focus of our trial has been working with Welch's Transport and Maritime Transport, using their real-world data to test the effectiveness of our product. And through this process, we've been able to further develop our product to be better suited for the UK market. What we've gained from the program is threefold. We've learned a lot from both our partners and from the support program. Secondly, we are much more confident in the product that we have to sell to the market and how to access the market. And thirdly, we've come away with some really fresh ideas that we wouldn't have gained otherwise.
So Gaussian is a company that develops magnetic enhanced components that bolt on into any battery and can result in up to 6 times faster charging and 8 times longer lifetimes. With this trial, Gaussian sought to understand how to integrate the maglev technology onto freight vehicles with negligible modifications to its architecture. An entire fleet of freight vehicles can be upgraded overnight, immediately unlocking ultra-fast charging at minimal cost. There is no other technology in the market that can offer this speed of deployment. Maglev can offer this at a tenth of the price and in days rather than years.
Chul deploys battery-integrated DC chargers, and this is software-defined hardware. So we put DC chargers in all the places that enterprise fleets need to charge, but find it difficult. Our systems bring together the best of a big battery that you might think from energy storage, and DC charging that you'd recognise from charging up your own EV. And we put those together, and that allows us to provide a very high power charge in environments where the grid couldn't normally sustain that kind of charge. Very few depots have enough electrical capacity to charge all of those vehicles. So you're stuck between a multi-million pound multi-year upgrade of the grid or our system, which can be dropped in place live within 24 hours at a fraction of the price. The program's really interesting because it combines not just funding to provide a demonstration project, but it also allows you to get close to organisations on the inside and as an insider. And that's incredibly useful for us.